Hello everyone. We already discussed that nuclear transmutation reactions. In nuclear transmutation reactions, there is one target nucleus, which one is bombarded with fast moving, high energy projectiles. That small particle projectile is a particle used for bombarding the target nucleus. And when that target nucleus which one is stable, but because of that bombardment of that small particle, that stable nucleus become unstable, and that unstable target nuclei decay or become radioactive and exhibit decay process, that is converted into new nucleus, that is recoil nucleus, and that that eject small particle known as ejectile. This one is a example of that nuclear transmutation reaction, that is nitrogen 714 as a target nucleus, which one is bombarded by projectile, that is helium, that is He 24. Then that nitrogen target is converted into, by process of radioactivity, that converted into new nucleus, that is recoil nucleus, which is known oxygen 817, and it also emits small particle, that is proton, when that one is known as ejectile, that is H11. In this, and we already discussed that theory for that nuclear transmutation reactions, that is which theory, that is uh, that compound nucleus theory we already discussed. Then now we discuss that different nuclear transmutation reactions by using different particle as a projectile. Different transmutation reactions using different type of particles as a projectiles. First, we discuss transmutation reactions using alpha particle as a projectile. Alpha particle is nothing but He24, that is helium nucleus without electrons. Helium 2 4 means only nucleus of helium, which possess 2 neutrons and 2 protons, and no electrons, therefore that possess 2 positive charge. We know that here, if alpha particle is a projectile that possess plus plus charge, 2 positive charge, and target nucleus, that one is used for bombarding target nucleus. That target nucleus is also positively charged. Therefore, because of positive charge of helium particle, there is barrier potential, barrier energy, barrier for, or difficulties for entry of that particle, alpha particle, into the target nucleus, because of positive repulsive force. And that entry, that barrier energy or barrier height, that one is known as barrier height, which is calculated by the equation phi is equal to z1 into E, z2 into E upon R1 plus R2. What is z1? That atomic number of nucleus that is R1 R2 radii of nucleus and alpha particle. Here Z2 is that for helium atomic number. Then examples of that transmutation reactions carried out using alpha particle as a projectile. First example is alpha p reactions. Here in bracket, first written is nothing but projectile and second is nothing but ejectile. Projectile first and ejectile second. That is in this case alpha p reactions. That means alpha particle is projectile and proton p is nothing but ejectile. In these reactions, alpha particle projectile and proton as a ejectile. Here first example is nitrogen 714 plus alpha particle, that is He24, that gives oxygen O817 plus 1 proton H11. Then second example, transmutation reactions using proton as a projectile. Proton, that is H11, hydrogen nucleus. It is nucleus of hydrogen, carries one proton only, no neutron, only one proton. Therefore charge is 1 plus. Since it is positively charged and target nucleus is also positive, therefore here also for its bombardment, here also existence of that positive repulsive force, and therefore possess barrier potential or barrier energy, which one is equal to phi is equal to Ze into E upon R1. Then here Z is nothing but Ze is nothing but that atomic number of that target. Then example of this type is proton neutron reaction, PN reaction, proton neutron. Here proton is written first because that one is projectile and neutron is ejectile. PN reaction. Example, sodium 1122 is bombarded by proton, that is H11. It gives magnesium 1223 plus ejectile as a neutron, that is N01. Then P gamma reactions, that is gamma radiations. Lithium 37 plus H11, it gives beryllium 48 plus gamma. Then P alpha reactions. Proton is projectile, alpha is here ejectile. Example, lithium 37 bombarded by proton H11, it gives 2 nuclei of alpha particles, that is He24. Then PD reactions. P is proton, D is deuteron. Projectile is proton and ejectile is deuteron. The example, beryllium 49 bombarded with proton H11, it gives beryllium 48 plus H12 means deuteron, isotope of hydrogen. Atomic number 1, mass number 2 means deuteron, H12. These are some examples of that, which reactions P proton as a projectile. Then transmutation reactions using deuteron as a projectile. Deuteron is isotope of hydrogen which contain one neutron and one proton. One neutron, one proton. Therefore, mass number 2, atomic number 1, that is H12 or D12 or D12. Deuteron has no any charge, it is neutral, and therefore no barrier energy, no nucleus repulsion is there. Therefore, it is also good projectile because no barrier is there. And therefore, examples of this deuteron as a projectile reactions, that first is DP reaction, that is projectile is deuteron, ejectile is proton. Here lithium 37 plus H12, it gives lithium 38 plus H11. Then cadmium 48114 plus H12, it gives cadmium 48115 plus H11. Then DN reactions, projectile deuteron, ejectile neutron. Here almost all elements show these reactions as tritium, which is isotope of hydrogen, that is H13 or T13 plus deuteron D12, it gives He24 plus neutron as a ejectile. Then D alpha reactions, projectile is deuteron, ejectile is alpha. Here lithium 36 bombarded by H12, that is deuteron, it gives 2 nuclei of helium, that is He24. Then D gamma reactions, because of loose combination of protons and neutrons in deuteron, such reactions are not observed, that is D gamma reactions are not practically observed. Then last, transmutation reactions using neutron as a projectile. Neutron, that is N01, that is no charge, only 1 unit mass, 1 AMU mass. Neutrons are best projectiles. Neutrons are best projectiles. Why? Because neutrons are neutral, hence no any charge, and hence do not experience any energy barrier, no any barrier potential for its bombardment on that target nucleus. Then the target and second reason why it is best projectile is that target nucleus, because of small size of that neutron, that target nucleus easily absorb neutrons having low energy also. Therefore, because of these two reasons, neutrons are the best examples of, or neutrons act as best projectiles. In that uranium fission reaction also, we already known, all of you known, that neutron act as a projectile. Then examples of transmutation reactions having neutron as a projectiles. First is NP reaction, that is N is projectile, P is ejectile. NP reaction. Helium 23, not 24. It is isotope of helium 24. This one is isotope. It is helium 23 bombarded by neutron 01. It gives tritium, nucleus of tritium 13 plus H11. Then N gamma reactions. H11, that is proton plus neutron, it gives H12. Simple hydrogen nucleus is converted into deuterium plus gamma radiations by loss of gamma radiations. These are the examples of nuclear transmutation reactions using different type of projectiles, that is neutron, deuteron, proton as a projectiles. Then we discuss that artificial radioactivity. We discuss this on later on next lecture. Thank you.